So in 6.6, we're solving radical equations. And even though you don't see the radical here, remember that we could change this to a radical equation with the cowboy and the horse. And for some of you, that might actually be easier. So if I wrote x plus 2 and change this to the cowboy and the horse, the cowboy would be 3, and so it would go inside the parentheses. And the horse would be a 4, and it would stay outside the parentheses. And then I would have the -1 and equals 7 from the original problem. Now here, if I use SADMEP to solve, I need to get rid of this 1 first by adding. If I add 1 to both sides, I get the 4th root of x plus 2 cubed equals 8, because the 1's cancel there. And now I can either cancel out the cube or I can cancel out the 4th power. Let's go ahead and cancel out the 4th root. The opposite of a 4th root is a 4th power, so I'm going to raise both sides to the 4th power. And when I do that, I'm left with x plus 2 cubed on this side equals, now let's see, 8 to the 4th. Well, I know 8 times 8 is 64, and 64 times 64, oh shoot, I need a calculator somewhere handy. There's one. I could do this on paper, but why bother? 64 times 64 is 4,096. Now I need to cancel out the cube by cube rooting both sides, and I get x plus 2 equals the cube root of 4096. So let's see, that is 16. And then I take 2 away from both sides, and I get x is 14. Okay, now I can check that by plugging it back in the original. In the textbook, what they're going to show you how to do is instead of changing it to a radical equation, you can solve this using rational exponents. So you can add 1 to both sides just like we did using SADMEP. We're adding first. We get x plus 2 equals the cube, or sorry, x plus 2 to the 3/4 equals 8. And now if I want to cancel out the 3/4 power, I can raise both sides to the reciprocal power, 4/3. When I do this, 3 over 4 times 4 over 3 gives me x plus 2 to the 1st, because 3 times 4 is 12, 4 times 3 is 12, and 12 over 12 is 1, so it's just to the 1st power here. And 8 to the 4/3, I get 16. And then you subtract 2 from both sides, and you get 14. Now notice if I go back in and check my work on this problem, I'm going to plug 14 in for x, so I have 14 plus 2 to the 3/4 power. I'm careful to put parentheses around the whole exponent, and then I subtract 1. When I hit enter, I should get 7 if I did everything right. And I do, so this problem checks. Now, in example number 5, since the radical is also already isolated, you just have to square both sides to cancel it out. When you do that, you have to be very careful of x plus 1 squared. You have to make sure to remember to times x plus 1 by itself. And then the square and the square root cancel and leave you 7x plus 15. Here we need to FOIL, so we're going to get x squared, and then plus x and plus x is a plus 2x, plus 1 equals 7x plus 15. And right now, since this is a quadratic, we know that we need to get 0 on one side. So I'll take 7x away from both sides, and I'll take 15 away from both sides, and we get x squared minus 5x minus 14 equals 0. Now, factoring is the fastest, so I think to myself, can I think of two numbers that multiply to 14 and add to -5? And I can in this case because I know 7 times 2 is 14. Let's see, if I need it to be a -5, then I want the minus to be in front of the 7. And so I get x equals -2 or x equals 7 as my solutions. Now, the original problem wasn't a square, and so there isn't necessarily two answers. To find out which one is the actual answer, I would need to go back and check my work. So on my calculator, I would be plugging in -2 plus 1, and I get -1. And then I take the square root of -2 times 7 plus 15, and I get 1. Notice the answers didn't come out to the same, which means -2 is not a solution. It's called an extraneous solution. And if I check 7, 7 should work.